Hello everyone, welcome to another Uiua programming video. Today we're looking at the Advent of Code 2018 Day 2 puzzle, and this one's pretty nice in Uiua. We get to make use of the group modifier, and in the second part we get to do some character arithmetic. So let's go ahead and get started with part 1. Basically, what we need to do is take a look at a list of strings, and in those strings, we need to count the number that contain exactly two of any letter, and then count those that have exactly three of any letter, and then multiply those counts, and that will get us the answer for this test input of 12. So I already copied this input into the pad, so we can go ahead and partition it as a first step. So the first thing we need to do is by not equal to the new line character. So by is a modifier that will call the not equal function, and it will keep the last argument, so it will keep this raw string on the bottom of the stack. So now we have our partitioning mask and our raw string on the stack. So now we need to use our partition modifier, and because it's a modifier, like by, we need to give it a function. So in this case, we can use the identity function because these strings are all the same length. If they weren't all the same length, then we would have to box them or do something else to account for that. But because they are, we can use identity, and we get our matrix of characters, or our vector of strings, however you prefer to look at it. And for part one then, we need to figure out how can we count the number of occurrences of each character. So to start with, let me pull out the second element because this one has some repeats. So the first thing we can do is use classify, and I'll again do by classify, and now you can see that the B's have been assigned 0, the ones, the A's are the ones here, and the C is the 2. So now we have a mask that we can use to group, and it says group elements into buckets by index. So this is perfect. And it's a modifier, so we need to give it a function. We can start by giving it box as a function, and as you see, this boxes all of the similar elements. But we actually care about the length, or how many of these there are. So we can just directly give it length as a function. And this now gets us what we expect. 3 B's, 2 A's, 1 C. And in fact, what letter they are doesn't matter. We just care that a 2 exists or a 3 exists. So now we want to check for that equality of 2 or 3. So we can put this 2, 3 vector on the stack, and we don't want to check for equality element-wise. We want to check for 2 across all the elements and then 3 across all the elements. So for that, we can use sided equals, and you point it at the argument that you want to repeat or fix. So now we can see exactly what we expect. I can put by here just for visualization. So now this top row is saying there's a 2 in this position, and the bottom row is saying that there's a 3 in this first position, which is exactly what we would expect. And what we actually care about is there any occurrence of a 1 in either of these rows? So for that, we can do a logical OR, and we need to apply it across the rows. So for that, we have our rows modifier. And in order to do a logical OR across, or let's say in between these elements, then we use a reduction, which is this slash here. And we can say to do a row-wise OR reduction. And this is perfect. So we see that there is a occurrence of 2 repeats, and there's an occurrence of a 3 repeat in this string. So now what we actually want is not to do it on just one of these strings, but on all of them. So we'll again use this rows modifier to run this function on each row here. And this gets us what we need. So this first column is a 1 if the 2 repeat is true, and the second column is for the 3 repeat. So now we want to add down these columns, and we can do that with another reduction, but in this case, rather than OR, we'll use add. And this tells us there are 4 and 3. And then to multiply in between this, we use reduction again, but this time with multiplication. So this gets us our part 1 solution. Now for part 2, what we need to do is we need to figure out which of these two strings differs in only one position. So how can we do that? In Uiua, we can use characters for arithmetic because they exist in what's called an affine space. It's not hugely important, but what matters is that if I have C and M on the stack, I can subtract them, and that will get me the distance between them. So this is very convenient because what we can do is, for example, we can take a look at the first two, and then, oh, and actually there is a separate test input. So let me grab that. And what we can do with these first two is we can simply subtract them. And this will tell us the difference between the characters at each position. So you can see here that the difference between A and F is 5, and the difference between B and G is 5, and so on. So this is great because if we can check the difference between all of these, what we're looking for is 4 zeros and a single 1. So in order to check that, we can take a look at, well, first off, the absolute value. That will remove the negatives in case we're subtracting in the other direction. Then we can look at the sign of the number. So this will give us a 1 for positive, -1 for negative, and 0 for zeros. And at this point, we're looking for this to have 4 zeros and a single 1. So we can simply add this up, and we'll use that same plus reduction. And in this case, what we've basically learned is that there are 5 differences between the first two strings. So how can we run this between all the possible combinations? So for that, what we need to do is use the tuples modifier, and this will get permutations or combinations. And how it works is a bit outside the scope of this, but what's important is that basically you can give it a subscript for the number of elements you want to look at, so in this case 2 because we want pairs, and then less than will get us the combinations. So now you can see we have the combinations of A, B, C, D, E with all of the other rows, and then the next element with all the other rows, except for A, B, C, D, E, right? So it's only combinations, not permutations. And now we have what we need. So we can start, and we want to look at each row separately. So each of these pairs separately. So we'll do this inside of the rows modifier. We'll do the subtraction, but now they're coupled, so we need to use reduce subtraction. But this gets us what we had before, all 5s for our first pair, and these are all the other pairs. And now we can simply apply the logic that we had. So do an AND reduction on the sign on the absolute value. And now we have the number of differences between all of the pairs. And we still are going to need those pairs, so let's use the by modifier. And we looked at by before. This keeps the last argument under the output. So with this now, we need to pull out the element or the pair at the index of this 1. So We can use rise for that. If I just do by rise, I can show you what this is doing. This is basically building a vector that shows how to sort this original vector. So what it's saying is that if you want to sort this original vector, you need to start by pulling out index 8, and then index 4, and 20, and then so on. So what we actually care about is just this index, because it is the index of the smallest. So we'll use first to get that. We'll use pick to get the pair that we care about. And now we have the two strings that differ in only one position. And what it actually asks us to do is return the characters that are common between them. So we can do that by, we can put these onto the stack. We're using first with a subscript of 2, so it will put the first two, the only two items, onto the stack. And then we want to check for membership. This will compare and see where one element exists in the other. And if we use by again with this, then we have the mask of what we want to keep, and we can simply use keep to get that answer. So this is our part 2 solution now. And I think it's pretty cool how we can use this grouping and these reductions to very quickly get our part 1 solution, and then for part 2 having this combinations capability and having the ability to pull out the minimum and keep by member is all very convenient. And I'll very quickly just add in the real input here, and there we go. Straight away, we have the real puzzle solutions in a very succinct and performant way. So thanks a lot for watching. Hope you enjoyed it. Hope you learned something. And I'll see you in the next one.